All right, if you were one of the lucky students that took intermediate algebra last semester, then this is going to be an extension of what we did last semester. So we're doing composition of functions. And my composition of functions always looks like the word fog. I can't ever quite make that little circle look like a tiny enough circle. It almost always looks like fog. So you're going to have to kind of deal with that. Okay. When it's written like that, it's just shorthand for mathematicians because they don't like writing f of g of x with all the parentheses over and over again. Okay, so we're going to start off with some slightly easier problems. So we're going to start with f of x equals 2x and g of x equals 3x squared plus 1. And on part A, we're going to do f of g of 4. Okay, so in reality, this means f of g of 4. Okay, so even if you did take it last semester, I know when I taught it, it's towards the tail end. So what it's saying is I'm going to take g of 4 and I'm going to solve that first. So I'm going to do g at 4, 3 times 4 squared plus 1 equals 3 times 16 plus 1. And I get equals 48 plus 1, which is 49. Okay, but I'm not done. This is saying g of 4 equals 49. So now I'm going to take 49 and replace it into the f function. So now I'm going to do f of 49. So 2 times 49 equals 98. So my final answer is 98. That's the one I plug into my math lab. All right, so now we're going to do g of f of 2. So again, I rewrite it. So we're going to do f of 2 first. F of 2. And I get 2 times 2, which is 4. So now I'm going to plug in 4 into the g function. Well, randomly enough, I just did g at 4. G at 4 is 49. So I don't have to go through all that work again. I just did that. So 49 is the answer to B. All right. New. Kind of an extension from what last semester. I know that this isn't in, it's not in intermediate algebra. We're going to do f of 1. Okay, which is f of 1. So we're going to do f at 1. Okay, well, that's f at 1 is 2 times 1, which is 2. So I'm going to take 2 and plug it into the f function. F at 2, well, we already did that. That's 4. So 4 is my answer. And then they're going to also have you do g of g, this time of 0. So g of 0. So g of 0 equals 3 times 0 squared plus 1. Don't assume that it's going to be 0. We get 1. So we're going to plug 1 in right there. So now we're going to do g at 1. 3 times 1 squared plus 1. 3 plus 1 equals 4. So nothing too far to extend on that one. All right. So now we're going to switch to where there's no numbers. So f of x equals x squared. G of x is x squared plus 4. And we're going to do the same order. We're going to do f of g, which is f of g of x. Okay, so anybody that struggles with this, replace g of x with x squared plus 4. So we're going to do f of x squared plus 4. Okay, so this says that I'm going to take x squared plus 4 and put it in for this x. Okay, so I get x squared plus 4 quantity squared. So I'm going to have to square it out, and I'm just going to do the perfect square binomial. X to the 4 plus 2 times 4 is 8, x squared plus 16. Okay, one other catch is they're going to ask you for the domain. Okay, so the domain of a function to the 4th power is going to just be all real numbers. There isn't anything here that's going to cause any issues. Okay, we'll find the one that causes us an issue here in a little bit. So let's do g of f. So g of f of x. Okay, so I'm going to take f of x and plug it into the g function. So g of x squared. Okay, so this one, take a different color. I'm going to put it in again just for x. So what happens is I get an x squared on the inside and a squared on the outside. Plus 4 gives me x to the 4th plus 4. Again, the domain isn't going to have any issues. All real numbers. F of f. So f of x. Okay, so f of x squared. Okay, so I'm going to plug it in again for x. X squared squared gives me x to the 4th. So I don't normally skip any of those writings. It does seem like a lot, but I'm not. I'm going to get negative infinity to infinity. All right, I'm going to go to the new page for the last one on this set. G of g equals g of x. So I get g of x squared plus 4. So I get x squared plus 4 squared plus 4. Well, I just squared out x squared plus 4 squared. You saw that. And I got x to the 4th plus 8x squared plus 16. But I also have this plus 4 on the back. So it's going to simplify to x to the 4th plus 8x squared plus 20. Again, all of these became x to the 4th, and their domain is all real numbers. No issues. You could put them into the calculator to double check me. All right. One more set of composition where there's 4 of them, and then we have 2 other problems that we'll look at. But one more long set. All right. 29. f of x equals 3 over x minus 1. G of x equals 2 over x. This is the tricky one. Okay, so if you didn't get 27, make sure you look at it a couple different times because 29 is really tricky otherwise. Okay, so we're going to go with f of g first. F of g of x. So it becomes f of 2 over x. Okay, so when I plug it in, it only goes in right here. And it's going to become complicated. Okay, so I get 3 over, this becomes 2 over x. That's where I substituted, minus 1. Okay, I can't leave it as a complex fraction. So what I need to do is take this denominator and multiply every term by it. So I'm going to multiply the top by x and the bottom by x. And what happens on the bottom is it distributes. Okay, so I get 3x on the top. And the x, when it multiplies by 2 over x, here's in the margin, times x. See that the x is crossed, so just get 2 minus x. Okay. This is also going to ask for the domain. There is going to be issues. We're going to use set notation. And the easiest way to describe this, there is another way in the textbook. But the easiest way to describe is what causes an issue in the beginning. And that's easy if you write out all the steps like I do. And what causes an issue at the end. So if we set those both equal to 0, x can't equal 0 on the first one, and it can't equal 2 on the second one. Okay, so we always look at what do we plug it in and what is the final answer. So we'll do g of f now. So again, I'm very diligent about writing out all the steps. So g of 3 over 3 over x minus 1. Okay, so this time it goes in right here. Okay, so I get 2 over 3 over x minus 1. Okay, so this time my denominator is this piece. So I have to multiply the top by x minus 1 and the bottom by x minus 1. So on the bottom it cancels out. On the top I'm going to distribute. So I get 2x minus 2 over 3. And then last but not least, I have to do my domain. What happened in the beginning and what happens at the end? Okay, so my domain is x such that x is not equal to 1. This piece right here doesn't have any issues because there are no variables. So there's only an issue with the first one. All right, so let's go and do f of f. F of x. So f of 3 over x minus 1. This one gets a little crazy. 3 over, here's my part I plug in, 3 over x minus 1 minus 1. Okay, so my denominator right here. So I'm going to multiply the top and the bottom by x minus 1. So Let me kind of take an extra step here that you don't have to do unless you want to. So this is 3 times x minus 1 over the bottom left turns into 3 minus 1 times x minus 1. So make sure you distribute correctly. This becomes 3x minus 3 over 3 minus x plus 1. So 3x minus 3 over, sorry, I made a mistake, over 4 minus x. Okay. Beginning, end. So my domain here is x such that x is not equal to 1 or 4. Last one, g of g. All right. So I get g of 2 over x. So it becomes 2 over x. Here's my denominator. So multiply the top by x and the bottom by x. So I get 2x on the top and just 2 on the bottom, which then the 2's cancel. So I get just x. So do be careful on this one. All right, then again, I'm going to look at the denominator of the beginning, and at the end, there is no denominator other than 1. So the domain here is x such that x can't equal 0. All right. Now that we're done with those ones, we got a couple other applied type problems. And this one's going to lead us to a problem, I think in 6.2 is where this one comes. So we're going to show one now and show another one in the next lesson. So we're going to show that f of g of x is equal to g of f of x. And the way to do that is by showing that they equal x. So they can only be equal if they simplify to x. They don't simplify to x, then they're not equal, okay? And we have to do it both ways. So f of x is 2x. G of x is 1/2 x, okay? And I'm gonna expect that you show your work, okay? Remember on the test, you gotta show your work. So make sure you understand how to do this. So this says f of 1/2 x. And then I'm going to plug it in right here. So this is a little easier than some of the others. So I get 2 times 1/2 x, okay, which obviously the 2's cancel. And I get just x. This one's perfect. So now I do g of f of x. Have to do both. So g of 2x. So I get 2 times, oops, sorry, did this backwards, I believe. Let's see. Now I'm going to do 1/2, yep, times 2x. So again, the 2's cancel, which is exactly what I wanted, and I get x. We'll do a slightly longer problem in another lesson. Okay. 47. We're going to find functions f and g so that f composed with g equals h if h of x equals 2x plus 3 to the 4th. Okay, So this one's kind of going to lend itself towards a bit of calculus, but that's okay. You can guess at it. No big deal. So knowing what we know, we're going to take one function and make it the inside. Okay, we've been doing a lot of, hey, f of x equals the whole inside. We're going to replace the inside. So go ahead and make one function 2x plus 3. All right, there's another function that's kind of underlying here, and that has to do with this fourth power. So we can't just put 2x plus 3 to the fourth. We have to worry about some variable to the fourth power. And so what we're going to do here is we're just going to make this g equals, and we're going to set up, again, we need to make sure it's the same variable so that when we compose them, we're just going to break the whole parentheses down to an x to the fourth power. So if you don't get it, no big deal. If you do get it, great, because that's where you're headed if you're going into survey of calculus, or if you're going the pre-calculus calculus track. That's where we're headed eventually. We're not going to get there in this class, but that's what this problem is showing. So some of the problems we see in college algebra lend itself towards where we're going.